Hi all. So this is a third lecture of object-oriented programming in Python. So in this lecture we will see the polymorphism. So we will see what is polymorphism. So it is taken from the Greek words poly, which means many, and morphism means forms. So the meaning of polymorphism is it is the use of a single type entity. So it may be a method, or it may be an operator, or it may be an object to represent different types in different scenarios. So it is to represent a single type of entity. If it is a method, we will use the same method name, and in two different contexts, it will do two different things. That is what is meant by polymorphism. So we have already seen polymorphism examples earlier. So if we have a variable num1 which is assigned 3 and num2 which is assigned 5, if we give num1 plus num2, you will get the result as 8. So this plus is a operator. This is an operator which will add these two numbers. Now, if we have the same thing plus operator, if we use for strings, if your str1 is hi and str2 is how are you, and if we use the same to add two strings, what happens is it will perform the concatenation operation. So this is also an example for polymorphism. This is operator polymorphism, because the same operator in two different scenarios works in two different manners. One is addition, the other thing is concatenation. So this is meant by polymorphism. So we have also seen this function polymorphism. So we have seen this length function. So if we are using len function, if for a string, it will give the number of characters, or the number of length of the whole string will be given. If we are using for a list, it will count the number of elements in that list. We'll get 3. If we are using it for a dictionary, it will give the number of keys in it. So the same len function can be used, will represent 3 different things in 3 different contexts. So this is meant by polymorphism. So we will see another example, polymorphism with a function and objects. So this is an example for polymorphism with function and objects. Here we have a class, we have two classes. One is class India and the second class is class USA. So we have named 2 different classes. So in India, we have defined 3 different methods. One is capital, language, and type. So all these 3 methods will be simply printing something. So this capital will be printing New Delhi is the capital of India. Language will be printing Hindi is the most widely spoken language, and type will be printing India is a developing country. Now we have another class USA which has the same 3 methods, capital, language, and type, but they are printing 3 different things here. Okay, so Washington DC here is the capital, English is the primary language, and USA is a developed country will be printed. Now what we have is, we have a function here. So we have a function here, func. The name of the function is func, which takes object as an argument, and inside that, what it does is that using that object, we will be calling capital, language, and type. All these functions will be called. So based on this object, if it is a USA object, all these functions will be called. If it is an India object, then all the methods of all these class will be called. So this is another function. Now we will come to the main program. So this is the main program. Here we are defining an object here. So we are declaring an object here, object underscore int equal to India. For this is an Indian object and this is an USA object. Now we are calling the function using the Indian object. So what happens is obj becomes Indian object. Now when we call obj.capital, so this function, this method will be called. Then when obj.language is called, this method will be called. And obj.type is called, this method will be called. So when we call this function, first it will be India. Then when we call the function using the second object, USA object, when we use that USA object, then the second, this will invoke all the second methods, USA methods will be invoked. So what we have to see is, depending on the object, different methods will be called. Even though we have the same names for all the methods, so based on the object, we are calling different methods. Okay, so you can run and see the program. If you run this, you can see that first Indian object will print these three things, and USA object will print these three things. Second function will print these three things. So this is known as polymorphism. Next type of polymorphism is class polymorphism. So Python allows different classes to have methods with the same name. So this is what we have seen. In the previous example also, we have seen this class polymorphism. There we have used a function to call those objects. And without using these functions also, we can call these objects. So here, Python allows different classes to have methods with the same name. So if you consider this example, so we have a cat example. We have a class called cat, okay, which has a constructor which gives the parameters are name and age. Then we have an info method which prints a cat. So you have to see this syntax. I have not taken the syntax earlier. So you have to see this print syntax, print, and I am giving inside this bracket, I am using F. This is known as F strings. So I am giving F, and inside this double quotes, I am giving the string. And inside this, my name, we are using a braces. Inside braces, I am giving self.name, and here I am giving self.age. So this F string, what it does is, when it prints it, whatever value is supplied here, self.name will be replaced with the value that is supplied here. So this braces and the self.name will be replaced by the value here, and also this will be replaced with the age value. For that, we can use simply F. So you can use capital F also. Instead of small f, you can use capital F also. Both are same. So these are known as F string. This is a new notation used in Python 3. Okay. Otherwise, you can use a different format, which I have taken another lecture. You can use str.format function. Format method is there. You have to use format. So instead of using format, it is easier to use. Simply what you have to do is you have to use F. And if you have to replace something, it will be automatically replaced. Here in this print function also, I am using a F, and inside this it will be self. Now when you run this program, you will see what output will be. Okay, we will come to that. So here we have a cat class which has a constructor and an info which prints what is there. Then we have a make sound also. Make sound function is there which prints meow. Since it is cat, meow sound will be there. Then we have a class called a dog. Here also there is a constructor. Then we have an info here which prints the data, and also a make sound is there. Here it prints bark. Now in the main program, what we do is we are creating an object for cat1, cat, and we are giving name and age. So this constructor will be initialized, and the name will become Kitty, and the age is 2.5. Then after that, we create another object, dog1, for dog. So this class, and the name will be Fluffy and age will be 4. Now we are using a for loop. So we are using a for loop here for animal in, this is a tuple, cat1 comma dog1. So what it does is, it's a simple for loop. So first it will take cat1, and so this animal will be cat1 dot make sound. So what it happens is, it will invoke cat1 dot make sound. So it will invoke this make sound. So meow will be printed. Then after that again cat1.info. So what happens is this statement will be printed. Then after that again cat1.make sound is there. So again meow will be printed. Then after the second repetition or in the second iteration, dog1 will be animal. Animal will be dog1 and dog1.make sound. So this will be called. Then after that dog1.info will be called. So this will be called. And after that dog1.make sound will be called. So this will call this one. So in this way this will be executed. So you will see the program. So if you run this, so this will be the output. So this will be the cat. In the first iteration, it will be like this. These three statements will be printed. The second iteration, these three statements will be printed. Okay. So what you have to see is when we do this thing, when the appropriate thing is obtained, when the appropriate object is used, the function, the method inside that class will be called. So even though we are using the same names, info and info, in this class also we have the same name, and also make sound and make sound are the same names. But when we use a particular object, only that class method will be invoked. So this is an example for polymorphism. So we will see one more example for class polymorphism. So this we have seen the same example before. We have class India and class USA here. Here, instead of that function, we are declaring two objects, object India and object USA. And instead of that function, we are using the for loop. For loop, and this is a tuple. So what it does is, first it will be object for India. So all these three functions will be called, three methods will be called, capital, language, and type will be called. In the second iteration, it will be USA, object for USA. Then country becomes object for USA. So these three methods will be called, and this will be printed. So this is the thing, same output as the previous one. So this is also an example for class polymorphism, the same classes. We have already seen these classes. Here we are creating two objects, one for India and one for USA. And we are using a for loop to invoke those objects. So this will be object.india first, then object.USA. So country becomes object_India.capital. So this capital will be called. Then after that, this language will be called, and after that, this type will be called. Okay. So in this way, this is also an example for class polymorphism. We are using the same method names in both the classes, but there are no relationship between them. But when we use the appropriate object, only those methods will be called. Next, we will see polymorphism and inheritance. So we have already seen we can define methods in the child class that have the same name as the methods in the parent class. So we have studied inheritance in the previous lecture. So in that lecture, we have already seen this inheritance, and we have used the same method name in child class and parent class. And we have seen the examples also. We will see it once more. So in inheritance, the child class inherits the methods from the parent class. All the methods of the parent class will be inherited in the child class. We can modify a method in a child class which was inherited from the parent class. So that's the thing. So if we are inheriting some method from the parent class into the child class, we can modify that method in the child class. So that is known as polymorphism. So the process of re-implementing a method in the child class, it is known as method overriding. We call this as method overriding. So what is method overriding? If we have the same methods in parent class and we inherit the same method in the child class, and if we modify that or if we re-implement that method in the child class, then it is known as method overriding. Okay. So we will see two examples for that method overriding. Okay, I'll see this example. So we'll see the first example. So this is the first example for method overriding. Here we have a class called bird. Bird class is there. So we have two methods. One is intro method and second one is flight method. So intro method, what it does is it just prints there are many types of birds. In the flight method prints most of the birds can fly but some cannot. Now we have another class called sparrow bird, and which is inherited from the bird class. So it is inherited from this class sparrow, and we are defining a flight method. So this is the same as of this flight, but what we print is different. Sparrows can fly is printed here. Then we have another class ostrich, which is also inherited from the bird class. And here we define a method flight, and ostrich cannot fly will be printed inside that method. Now what we do is we are creating an object for bird, object underscore bird. Then we are creating an object for sparrow, and we are creating an object for ostrich. Now what we do is we are going to call a method using this bird object, and you will be invoking this intro method. So intro method, so this is a bird object, so automatically this will be printed. There are many types of birds will be printed, so this statement will be printed. Then after that what we do is we are using the same object dot bird underscore bird object, and we are invoking flight. So since it's an bird object, so this flight will be printed. So this method will be invoked. This flight will be invoked. So most of the birds can fly, but some cannot will be printed. Then after that, what we do is we are using the object dot SPR, that is the sparrow object, and what we do is we are invoking intro. So inside the sparrow, we don't have an intro function. So what it does is it goes to this class bird because it is a parent class. So there is an intro. So it will print. There are many types of birds will be printed. Then after that, again we use that sparrow method to invoke flight. So here we have a flight method. So this here also we have the same method. The parent class and the child class have the same flight method, but the parent method will be overridden by this thing. So print sparrows can fly will be printed. Sparrows can fly will be printed instead of printing that's flight. So this is known as method overriding. So this flight method is overridden by this flight method. Now again we use the ostrich also. Ostrich dot intro means this bird's intro method will be invoked, and ostrich dot flight means here we have a flight method, so this flight will override. So ostrich cannot fly will be printed instead of printing this thing. So this is known as method overriding. So if you run this program, it will be like this. There are many types of birds will be printed. Then most of the birds cannot fly. So these are based on the bird object. Then after that, these two are based on the sparrow object, and these two are based on the ostrich object. Okay. Now we will see one more example. So this is another example for method overriding. Here we import this math because we are using this pi. So we need this pi. We are calculating the area of the circle. So we have a class called shape here, and in this shape we have a constructor. Then we have an area. So we have inside this method area, no statements are there. So if you are not including any statements, then an error will cause. So if we have to include something inside a method. So if we have nothing to include inside that area, we can simply use this keyword pass. So this may, in order to avoid that error, we simply use that pass. So this is to show that we can later develop. We can, if you want, you can later add something inside this. So if you want to add in the later stage, you can simply use pass inside a method. So there won't be any error here. This means that there is nothing inside this method. Later on, if somebody wants, you can add it. Then we have another method fact. It will return the statement. Then we have another str. We have already seen in the first object-oriented lecture. It will return the self.name will be returned. Then we have a square class. So this is inherited from the shape class. So all these will be inherited. All these methods will be inherited here. So this is a constructor of the square class, and inside this constructor we are using the super. So this means it will invoke the constructor of the parent class. So square's parent is shape. So this means it will invoke the parent constructor. So this will be invoked. So when we declare an object for the square, what it does is this constructor will be invoked, and this constructor, what it does, it will invoke the parent constructor. For that we can use the super. So instead of using the name shape, you can simply use this super and brackets dot init of square. Then we are defining another method here, area. So area, it is length raised to 2, length square. You know, a squared is the area, and we are printing something fact. Squares have have each angle equal to 90 degrees will be printed. Then we have another class called circle, which is also inherited from shape. Here we have a constructor, and this constructor also invokes its parent constructor, and a radius will be there, initiated, and we have an area here, the area method which is there, and it will return pi r squared. Okay. So these are the 3 different classes. One is shape. Shape we have the following methods, 1 constructor and 2 methods, and the str method is also there. Then square, we have the constructor, and area and fact is there. And circle, we have the constructor and area will be there. Now what we do is, we create an object for square, a equal to square of 4. So what it does is, so this constructor will be invoked, and the value is 4 here. 4 is here. So that value will be, length will be 4 will be here. And what it does is, it invokes the super constructor. That is, the parent constructor will be invoked, and the square name will be supplied there. So here the name will become square. Okay. So that the object name will become square. Now, and length will be initialized to 4. Self.length will become 4. Okay. Then after that, what we do is, we are declaring another object for circle, and we are giving 7 value. So what it does is, the radius will be 7. So this constructor will be invoked, and what it does is, it will invoke the parent constructor. That is, the shape constructor will be invoked, and the name circle will be supplied here. This name will be supplied there, and self.radius will become 7. Now what we do is, we are printing this b. We just print b. We will just print p. Okay, we just print the value p here, and after that, what we do is, we will print. So we are printing the object b. Then we will be printing b dot fact. You will see each and everything. So we will run and see what is the output first. So this is the output. So b means circle will be printed. Okay. So here circle print b, the circle will be printed because we are giving this b value is circle. So here that name will be printed here. Then what it does is, we will see the method overriding here. We are using the b dot fact. So here b dot fact. So we are using the object. B is actually the circle object, b dot fact, but there is no fact method inside the circle class. So what it does, so it will invoke the fact of this class, shape class. So this will be printed. I am a two-dimensional shape will be printed. Then again we are invoking a dot fact. So if we see inside this square there is a fact. So this will override this fact. Okay, this is a shape and this is the child class. This is a square, so it will return squares have angle equal to 90 degrees. Then again we are using print b dot area. We are using print b dot area. So what it does is, print b dot area means what it does is it will invoke b means circle class. So area is this one. So it will calculate pi r square and that value will be returned here. So this actually there is another area. There is an area inside this shape class, but there are no code. There is no code to execute, and moreover, we have to override it. We will be overriding it in the circle class, and we will be printing the area based on that. So that is why if you check this thing, it will be like this. So circle will be printed. So this is the first print of B, means circle will be printed. Then I am a two-dimensional shape will be printed. Then squares have 90 degree will be printed, and the area of that circle will be printed. Okay. So this is a thing we have seen. So in the main program, we have a print of B. So what it does is it will be invoking this str class. Print of B means it will be invoking that str method. So it will be invoking that str method. We have already seen in the object-oriented first lecture what this str method will do. So this is equivalent to str of B also. So that circle will be printed. Then print b dot fact means it will be invoking, even though it is a constructor for the second class, that is a circle class, there is no fact inside this circle, so it will be invoking the parent fact method. Then when we call print a dot fact, there is a fact method inside this square, so this will be invoked instead of this method, so there will be an overriding here. Then after that again print b dot area, so this area will be overridden, or there is another area inside this shape class, but that won't be executed, only this child class area will be executed. So it's because of method overriding. So these are the references. Thank you.